Hello. Now the question is find range of A. What are the permissible values of A if this equation has some real solutions, and in some particular cases you can find solutions also. So in this case there can be two methods. One method is convert in A sin x plus B cos x is equal to C form. Sin square x can be written as 1 minus cos 2x upon 2, and this can be written as 1 plus cos 2x. Then we can simplify. So both methods I will discuss briefly. Method 1, I can write sin square x as 1 minus cos 2x upon 2 minus 1 upon 2 sin 2x minus 2 cos square x is 1 plus cos 2x is equal to A. Multiply by this 2. So we will get 1 minus cos 2x minus sin 2x minus 2 minus 2 cos 2x is equal to 2A. So this can be written as 2 and 1 3 minus 3 cos 2x minus sin 2x is equal to 2A plus 1. This quantity will go this side. So minus 1 will become plus 1. So 2A plus 1. So A sin x plus B cos x is equal to C. So 2A plus 1 must be greater than under root of 9 plus 1 under root 10 minus, and this must be less than plus under root 10. So from here 2A minus 1 adding both sides, so A must be greater than minus under root 10 minus 1 upon 2, and this must be less than under root 10 minus 1 upon 2. This gives a range of A. The same question we can solve by another method. In this method, let us take sin is A into 1, and this one is sin square x plus cos square x. So everything we are converting in sin and cos. Minus sin x cos x minus 2 cos square x is equal to A. I can multiply this by 1, sin square x plus cos square x. Now transfer all the terms to one side. So I can write this equation as transferring all the terms to one side. 1 minus A sin square x. From this term and this term I am taking sin square x outside. Minus sin x cos x. Then again cos square x is outside. So this will become minus A cos square x. So minus A plus 2 cos square x is equal to 0. Now in this case cos x cannot be 0. Because if cos x is 0, this is 0, this is 0, that means sin x is equal to 0. So both cannot be 0 at the same time. So if cos x is not equal to 0, cos x equal to 0 makes no sense. So we can divide by cos square x. So first case we will take let A is not equal to 1. So let A is not equal to 1. Then dividing both sides by divide by cos square x both sides. So we will have sin square x upon cos square x is tan square x. So 1 minus A into tan square x minus tan x minus A plus 2 is equal to 0. This is quadratic equation in tan, and tan can have any value from minus infinity to plus infinity. So for this equation to have real roots, we must have d greater than equal to 0. That must give answer for this. So d means b square minus 4ac. b square 1 minus plus 4 into 1 minus a into a plus 2 must be greater than equal to 0, or 1 plus 4 a plus 2 minus a square minus 2a must be greater than equal to 0. So this will be how much? Minus 4a plus 8 plus 1 9 minus 4a square must be greater than equal to 0. So we can write this as 4a square plus 4a minus 9 must be less than equal to 0. So now we can find its roots. What are the roots of this? So a is equal to, roots are a is equal to minus b plus minus under root b square minus minus plus 4ac, b square minus 4ac, 16 into 9 144 upon 2a 8. So this is equal to minus 4 plus minus 150 160 upon 8. So this 16 we can take outside. So this is minus 4a is equal to minus 4 plus minus 4 under root 10 upon 8. So roots are minus 1 plus minus under root 10 upon 2. Now the equation is, if you observe here, this equation is in the form of less than 0. That means my solution will lie between the roots. So a belongs to, smaller root is minus 1 minus under root 10 upon 2. So this gives that same answer we will get from here. A belongs to minus under root 10 minus 1 upon 2 to under root 10 minus 1 upon 2 between the roots. So from both you can see this answer is same as this answer, both answers are same. Now there is a special case here. What happens when a is equal to 1? So just I have taken one case when a is not equal to 1. Second case is if a is equal to 1. This case we have to deal separately. If a is equal to 1, this will be 0. Then we can solve directly. Sin x cos x plus 3 cos square x is equal to 0. Take cos x outside. Sin x plus 3 cos x is equal to 0. So from here we will get the solutions of this equation. Sin x is equal to 0 and tan x is equal to minus 3. So two things will come. Cos x is equal to 0. Cos x is equal to 0 and sin x is equal to minus 3 cos x. So tan x is equal to minus 3. And this will give me answer. Cos x is equal to 0 is not the solution of this equation. You can check here. If cos x is equal to 0, this is very important. If cos x is equal to 0, if you put here cos x is equal to 0 in original equation, then what will happen? This is 0, this is 0. So that you have to identify. If cos x is equal to 0, then check what happens. You will get sin square x this is 0, this is 0 is equal to 1, which is possible. That means cos x is equal to 0 is one of the solution. So you will get x is equal to 2n pi. So x equal to 2n pi we will get from here. So cos x equal to 0, that is why we are able to divide by cos square x. So this is one of the solution. Next, tan x is equal to minus 3. So x is equal to, from here we will get n pi plus tan inverse minus 3. This is special case when a is equal to 1. Otherwise a can have any value between minus under root 10 minus 1 upon 2 to under root 10 minus 1 upon 2.